Siri, buy my phone. Oh, God. I better shut up before I get in trouble. Okay, so we got two things to bring into play today. We should be able to do an explicit equation by now. So today we got to work on a recursive equation and graphing, okay? You'll see they're all going to relate to each other. So if you have an explicit equation, you can figure out the recursive equation and the graph. If you have the graph, you can figure out the two equations. If you have the recursive, you should be able to figure out the graph. Holy moly, there's already too much. All right, so here's the sequence, right? 3, 7, 11, and 15. Your first job is to find the common difference. So how do you get from one number to the next, right? So the pattern, and in this case, you're going to add 4. And remember, keep paying attention to the colors. I keep using the colors for a reason. I'm color coding everything. So this is your common difference, right? And each term has a specific number associated with it. So like 3 is the first term of our sequence, so 3 goes with 1. 7 is the second. 11 is our third term. 15 is our fourth term, right? Actually, let me redo those real quick in red. And then to do the explicit equation, you can use all of these terms, or you can go back and find the 0 term, right? In our 0 term, if we go backwards, we're going to add 4 to go to the left, so we're going to subtract 4 to go to the right. So that means our 0 term is -1, because 3 minus 4 is -1, okay? This idea is going to get super important. Okay, so here's your first thing. What we're actually dealing with isn't just straight line y equals mx plus b. We're dealing with something called functions. When you have a function, you have one x value that has one y value, all right? And it basically, let's keep it simple, it works that way. So every x value, let's say you put it into like some machine, and crank it, and then it spits out a y value, right? And if you always put that x value in, the same one, you'll always get the same number. If you put a different x value in, you better get a different number. So in our case, we have that. So our 0 term is -1, first term 3, second term 7, and so on, all right? We can build our explicit equation from this. But now instead of y equals mx plus b, I'm going to start using function notation. And all I'm going to do is just replace the y and the f with an f of x. F of x. Okay? Each letter is still going to be the same thing. Okay?
Okay.
Okay?
Okay.
So instead of y, from now on, I'm going to start writing the function of x is equal to 4, because that's our common difference or our pattern, x plus -1, right? And remember, our common difference is our slope of the line. And our b is our y-intercept. Intercept, or our 0 term. And the reason why this is important is for a few reasons. If you have this sequence, you can go into graphing right away. If you have the equation, you can go into graphing right away too. So I'm going to skip the recursive real quick and then just go right into the graph, all right? I'm going to do this 2 different ways, and I got to hurry up because the video's running. This part right here, the blue, -1 is our y-intercept, right? So it's our 0 term, okay? So that means that on the y-axis, you can put a dot on -1. So the y-axis, remember, goes up and down. So here's 0, 0 in the middle, right? -1 on the y-axis is right here. All right, that -1 you can put it in right there. All right. Our slope is positive 4, right? And slope is our m value, but that's equal to rise over run. And when you have a whole number, 4, there's always a number underneath it, which is just 1, okay? So that means that we're going to go rise 4, because it's positive, so we're going to go up. And then the positive one at the bottom means we're going to go to the right. Okay?
Okay.
Okay?
Okay.
If the number was negative, you would go left for the rise or down for the run. But neither one of them are negative, so we don't have to worry about that right now. So our slope gets counted as like this. We're going to go up from this dot. 1, 2, 3, 4, and over 1. Okay? And then just do it again. Up 4, 1, 2, 3, 4, over 1. All right, and there's our next point. Okay, and then let's go, well, we can't fit it, okay? But we can also go back down. So down, 1, 2, 3, 4, but we got to follow the pattern, go left 1. Okay, oops, that was only 3. So 1, 2, 3, 4. Okay, now here's where the slope came in, right? Our common difference, our slope, it was counted right there in the up 4 over 1, okay? Here's where it gets a little cool. This point right here, 0, 1, we can rewrite all of these terms as coordinates, right? So 0, 1 can be rewritten as a coordinate 0, 1, right? Well, that is our y-intercept, and that's what we said with the 0 term over here. So this coordinate, oops, this coordinate is 0, 1, right? The next coordinate is 1, 3. So we can rewrite it as 1, 3, and that is right here. This point, 1, 3. We go over 1 and up 3, and then it'll follow the pattern still. So the next coordinate would be 2, 7. And then the next one would be 3, 11 if we kept graphing, okay? Let me see if I can, no, that's good, as good as it's gonna get. All right, so you can graph with just the equation, or you can graph the coordinates or the terms when you have the sequence, all right? So that took care of our graph. Now here's the tricky equation, is our recursive equation. I talked about this in the first video, but the recursive equation, if you remember, it needs a starting point, and it needs a repeating pattern. Okay, so your start point can be any of the terms given. All right, so I gave you up here 1, 3 or 2, 7. When x is 3, let me start that over. I gave you when x is 1, y is 3. When x is 2, y is 7. When x is 3, y is 11. Okay, and we're gonna have to write that mathematically. Oh, that is one thing you have to remember. Written in math language. And then our pattern, you're gonna need the common difference. But again, it has to be written in math language, okay? So here's the answer for a recursive equation. You could write f of 1, so the first term of the sequence is equal to 3, okay? And then you would separate that with a semicolon or just write underneath it. Then you would tell me that the function is equal to f of x minus 1, which actually means the previous term or the last term plus 4. And the reason why plus 4 is because you want to tell me to count by 4s from the common difference, or with the common difference, okay? So what you're really saying, if I was to write this out, you're like, all right, Gonzalez, the first term, I'm right here. The first term right here is equal to 3. So I would write 3 down, okay? Then this math language over here on this side is telling me, okay, now the function is equal to the previous term. So right now, this is my previous term, or my last term, okay? What am I gonna do to that last term? Well, I'm gonna add 4 to get the next term, which is 7, okay? Make sense? And then if I want the third term, what am I gonna do to the third term? Well, now 7 is my last term. And what am I gonna do to 7? I'm gonna add 4, which is this part of the equation, to get 11, all right?
Oh my God! Wow!
Okay, so in the video, I just showed you how to write an explicit equation. We've already done it. Graph from the explicit equation or from the coordinates that are given. And the last thing was to write a recursive equation, okay? We're gonna make sure you answer the questions and that I'm gonna give to you next, and make sure you're following along and taking notes during the live part of the lesson, all right? I hope it was good. I'll see you guys in a little bit.
Bye, have a great time.